What is up? Welcome back to my YouTube channel. So I hope that you guys are having a great Mardi Gras break. And today I will be discussing lesson number 10, angle problems and solving equations. I will also continue this to lesson number 11 because they are connected to each other. So I hope that this particular lesson will also help you to do your project. So without any further ado, let me start with our lesson. So before we can consider ourselves that we already know on how to do angle measurements and stuff, so the process is pretty much the same whenever we are solving equations. But the thing here is that there are particular things that we want to know. So first and foremost, the adjacent angles. So given the particular diagram, as you can see here, all right. When we say adjacent angles, those are two angles. All right. So two angles that has a common side. So it means they are next to each other. So just like this, angle BAC. All right. Angle BAC, it's this one. All right. It's this angle here. And angle CAD is adjacent. There's no particular symbol that we can use, but rather just using ADJ. All right. So remember, whenever we are naming angles, the most important thing is the one on the middle. All right. So if they are next to each other, just like this, as you can see here, they are next to each other, therefore they are adjacent. Now, vertical angles. Vertical angles basically, having a vertical line. Doesn't matter if it's horizontal or vertical. It's just vertical angle. Why? Because it's taking note that it is vertically opposite to each other. All right. They're vertically opposite. So just like this, angle DCF, I'm naming this, this, and this. So it's this angle and this angle. So as you can see, they form a vertical line, even though it's a horizontal line. I know, right? So angle GCE. GCE. All right. So if two angles are vertical to each other, therefore they are congruent. Congruent, when we say congruent, it means they are equal to each other. Same goes with angle DCG here, this angle here, DCG, and angle FCE. All right. So you can see they are vertical to each other. So therefore we can perform a vertical opposite angle wherein they will be congruent. Now, angles on a line. Whenever we are talking about angles on a line, what you need to do or what you need to remember, all right, is a perpendicular form of a line. So it means they are going to create a 180-degree angle. All right. So it means adding ABC, adding angle ABC and angle CBD will result to 180 degrees. So it should be a straight line. It doesn't matter, it doesn't matter where the direction of the other line is, even though it goes here as well. As long as it forms a 180 degree, that's an angle on a line. All right. So it means two angles that form a 180-degree measurement. Okay, and of course, angles at a point. So the point that is being pertained here is this one wherein two or more lines intersect to each other and they have a common point. And whenever we are looking for the angle around it, all right, that is 360 degrees. All right, so it means, what do we need to add? Angle BAC, angle CAD, and angle BAD. All right. I hope that particular lesson helps on how to know whether a point, whether an angle is an angle at a point, angle on a line, if they are vertical angles, or if they are adjacent angles. So those are the four most important things for now. There are a lot of things that we need still to remember, but I'm not going to jump on that. So vertical angle. So as you can see here, angle CEA is vertical to angle BED. All right, so angle CEA is congruent, therefore, to angle BED. So if you see that, therefore, you can also say that the other side, this one and this one, they are also vertical angles. All right, so that is angle CEB is congruent to angle AED. Okay, so if you're going to check that, whenever you add the 79, 48, and 90 and 37, I am for sure that going to be um, that is going to be equal, that they are the same, that they are congruent. All right. Now adjacent angles. There are a lot of adjacent angles. Just look at this. Angle CEA and angle CEF. They are next to each other. This one and this one. All right. You can also tell me CEF and angle FEB, they are next to each other. So as long as they are next to each other, they are adjacent. All right. Angles on a line. Therefore, if this is a straight line, okay, we can add all of these three or all of these three. They will create a 180-degree angle. Angles at a point, all of it. Name them. Angle AEC, CEF, FEB, BED, DEG, GEA. That's the angle on a point. Just remember the 180 degree and the 360 degree whenever we're talking about a line and a point. So for this one, estimate the measurement of x, wherein it's this one. So I would probably say, it's a 45 degree. It's just an estimate. It's not, pertaining to a particular one. So in a complete sentence, describe the angle relationship in the diagram. So what we can say is that angle BAC, this angle here, all right, is perpendicular, or yeah, angle BAC, sorry, and angle CAD will create, of course, an angle on a line that is 180 degrees. Or you can tell me also the sum of angle BAC and CAD is equal to 180 degrees. So now write an equation for the angle relationship shown in the figure and solve for x. So as you said, adding them, angle BAC plus angle CAD is equal to 180 degrees. So BAC in x plus CAD is 132 is equal to 180. Now I hope this one is very much familiar for you. As you can see, we now have an equation, therefore we can use APE, SPE, MPE, DPE. All right, so for this one, since that this is a plus, of course we're going to use SPE. So subtract both sides by 132. So x is equal to, what is 180 minus 132? 48 degrees. Therefore, that is the measurement of angle x. If you're going to check it with using a protractor, I bet you guys it's going to be the same. So in a complete sentence, describe the angle relationship in the diagram. So what can we say? Of course, the sum of, as we can see, if we can notice, it's already a straight line. All right, therefore it's going to be an angle on line, so it means it's going to be 180. Now there's this symbol here. It doesn't have any measurement, as you can see, but there is a symbol that is a square. If you see that particular symbol, that means that is a right angle. A right angle is going to be 90 degrees. So the sum of angle BAC, CAD, and DAE is going to be 180 degrees. All right, find the measurements of BAC and DAE. So it means adding the three of these angles, this angle here, this angle here, and this angle here, we're going to have 3x plus 90 plus 2x is equal to 180. Now, what's our first step? Combine like terms. So what are the like terms? Of course, it's 3x and 2x. So 3x plus 2x is 5x plus 90 is equal to 180. Now we remove the 90 because we need to remain the one that has the variable here. Subtract 90 here, subtract 90 there. So we're going to have 5x is equal to 90 and 5x, all right? So our next step, since this is an integer, we can use DPE by dividing both sides by that particular 5. Therefore, x is equal to, what is 90 divided by 5? That is 18. All right. Now, since we are being asked for the measurement of angle BAC, this angle, and angle DAE, this angle, it says here it's 3x and 2x. What should we do? Of course, we need to substitute. Substitute. All right. So that will be 3x. Therefore, that is 3 times 18, wherein that is 54 degrees. We got 2x is equal to 2 times 18 is equal to 36 degrees. There you have it. If you're going to add all of this, you're going to see it's going to be 180 degrees. Now this one. So I'm not going to, really elaborate it. So as you can see here, there are two straight lines, and if you can see, this one is congruent to this one, and this one here is congruent to this one. So as you can see, it's like a cross, right? They were able to cross each other. Therefore, that is going to be vertical angles. They are vertical to each other. So therefore, this y here is going to be 144. Now, how do we solve for this x here? All right, since this is a straight line, all right, so y is equal to 144 degrees. So as you can see, line LEK, all right, or line LK. Line LK is a straight line. Since that it is a straight line, therefore line LK is equal to 180 degrees. It means this particular angle here is going to be 180 degrees. And how do we solve for x? Since you already have a y, we need to subtract, right? Or basically it's just going to be like this. X plus y is equal to 180, right? X, this one, plus y, this one, is equal to 180. X is unknown, plus y is 144, is equal to 180. Subtract both sides by 144. X is equal to 36. There you have it. As easy as that. Now this one, right? So for this one, we have here, write an equation for the angle relationship shown in the figure and solve for x. Okay, so basically we're just being asked to solve for x. But before that, before we go to anything there, what can we notice? This line here and this line here, they are crossing each other. What does that mean? Basically, they are, yes, they are vertical to each other. All right, but is it just this one here? No. Extend. So as you can see, it's like ray n, all right, or ray en is just a ray, so it means it was from here going there, so it means it's not basically a line, it's a ray. So since it's a ray, therefore it is just like a separator. It was just put there, you know, for you to analyze it properly. So therefore we can create an equation since that angle JEM is congruent to angle KEL. We can say that 3x plus 16 is congruent to 85. Now we can solve. We need to remove the 16 here. So 3x is equal to 69. And then we divide both sides by 3. X is equal to 23. Are we going to solve for 3x? No, it just says solve for, sorry, x. Now for this one, what can we say? Right? What can we say on this one here and this one here? Some of you might say it is vertical. Yes, they are. Okay. But for us to ensure that they really are vertical, because some of you might say they are adjacent angles, how can they be vertical, right? You're going to see it through this equation. So since that we were given this angle here, which is a 90 degree, and this is 135 and this is unknown, and since that it's going to create a circle and there is an angle at a point, right, it's going to create a 360 degrees. So it means adding GKF, angle GKE, and angle EKF, all right, it's going to be 360 degrees. GKF is 135. GKE is 90. Plus EKF is X is equal to 360. Now what is 135 plus 90? 225 plus X is equal to 360. Remove this on both sides. X is equal to 360 minus 125. Yes, 135. So as you can see there, all right, even though that they are adjacent angles, we can also say that they are also vertical angles in such a way. All right. Next one. So this one. Find the measurement of angle GAH. So what can we observe? They were all given the angles, right? So if you were given all the angles, it means it's going to create 360 degrees. It means it's an angle at a point. So it means by adding angle EAF, angle FAG, angle GAH, and angle FAH, it's going to create 360. So EAF is this one, 103, FAG, 59, plus GAH, x plus 1, EAH is 167 equal to 360. So adding these three numbers here, okay, that is 103 plus 59 plus 167 is going to create, oh, by the way, do not forget to add also, of course, the 1. All right, even though that there is a parenthesis here, it's just going to be a separator. Okay, so adding those 4 numbers, we're going to have 330 plus x is equal to 360. Okay, So subtract 330 here, subtract 330 there. X is going to be 30 degrees. But are we done? No. It says here x plus 1. So it is 30 plus 1, 31 degrees. All right. All right. The following two lines intersect. The ratio of the measurements of the obtuse angle to the acute angle in any adjacent angle pair in this figure is 2:1. So it means the obtuse angle here is going to be the ratio 2, and the acute angle is going to be the ratio 1. So therefore, of course, as you can see that this one here is the acute angle, so we're going to have it as 1x or just x, right? And then 2x. All right. So label the diagram with the expressions that describe the relationship, write an equation that models the angle relationship, and solve for x. Find the measurements of the acute and the obtuse angles. So you might ask me, how can you possibly solve this with no given number, with no given measurement of an angle? That's where you're wrong. There is a given measurement, but in the form of a term, in the form of an unknown variable x. So it means if you're going to look at it, okay, you cannot use the vertical angle, all right, because there's no number there. Vertical angle, it only indicates that they are they are congruent. But what can we notice more? We can either use the 180 since that there is a straight line, all right, or the 360 wherein it's going to you were given all the angles, so it means you can add all of them and then equate them to 360. But let's not, make ourselves suffer. Let's just add 2x and 2x and x and then equate it to 180, which is going to be much easier. So 2x plus x is going to be 180. 2x plus x is 3x. Divide both sides by 3. X is going to be 60. That is the solve for x. Now that is the measurement of this acute angle here. Now how about the obtuse? Of course, we just need to multiply it by 2. So 2x is going to be 2 times 60, wherein 2 times 60 is 120. As you can see, if you can add all this, 120 plus 60 is 180, plus 120 plus 60, 180, 360. Okay. So I would probably stop there. Okay. I hope that you guys were able to understand lesson number 10 so that you can have a much clearer way or understanding of how to do it. So I will see you on the next lesson. I hope that you guys will be able to do your project and have a good night. Bye.